Looking back, it's tempting to view Earth's history as a gentle, gradual climb, a slow 4 billion-year march from simple single cells and primordial oceans all the way to sprawling neon-lit modern cities. But the geological strata tell a much more erratic story. The planet doesn't just slowly adapt, it undergoes violent, rapid resets. These sudden planetary reorganizations are known to scientists as flips of state. During these transitions, the entire physical reality of the globe is rewritten. A world completely encased in miles of expanding glacial ice can rapidly transition into a completely alien, lava-scorched hothouse with an unbreathable atmosphere. Our current climate stability, the window that allowed human civilization to flourish, is not a permanent fixture. It is a temporary holding pattern, and the geological timer is always counting down to the next reset. When we think about global resets, we usually picture giant space rocks. We look at the fossilized remains of apex predators and imagine a massive asteroid wiping out the dinosaurs in a fiery flash. While those external impacts certainly happen, the most profound, permanent flips of state in Earth's deep time originate from within. The primary driver of these planetary overhauls is biological life itself. There is a hidden pattern buried in the rocks. Every time life reaches a new, critical stage of biological evolution, the planet reacts. The Earth and its inhabitants co-evolve, locking together in a cycle where major biological upgrades trigger severe planetary flips. If major shifts in life consistently force the planet into a new physical state, we have to look closely at the single species currently dominating the globe. We are the most likely trigger for the next transition. This chart illustrates the earliest mechanics of coevolution. 4 billion years ago, simple prokaryotic cells didn't merely survive in their environment, they actively dismantled and rebuilt it. By existing and multiplying, they manipulated the planet's chemical makeup. Then, life found a way to store data. These early organisms developed the ability to encode complex genetic information into RNA and later DNA molecules. This leap in biological information processing allowed microscopic organisms like cyanobacteria to harness photosynthesis on a massive scale. They pumped out so much waste gas that they forced the planet's surface to flip from a chemically reductive state to an oxygen-rich one. Later, cells developed an even more efficient way to share and process data. A larger cell absorbed a smaller prokaryote, incorporating its genetic material to create the first eukaryote. The absorbed cell became an internal power plant, a mitochondrion or chloroplast. This establishes the core rule of the Earth's engine. Every time biological life invents a superior method for processing information, the planetary environment is forced to radically alter its physical state to accommodate the new system. As single cells joined together to form multicellular organisms, information processing leveled up again. This led to the development of the centralized brain, a command center capable of real-time learning and environmental manipulation. But the system hit a critical threshold when one specific primate species ran out of biological storage space. Humans began encoding data outside of their own bodies, pressing symbols into clay tablets to create written language. From those first clay tablets, external processing exploded. We moved from vast physical libraries to global digital computer networks, connecting billions of minds and servers in a continuous, high-speed feedback loop. Humanity's technological infrastructure acts as the modern successor to those ancient DNA upgrades. This global grid of satellites, undersea cables, and energy-hungry server farms applies a similar physical load to the planet, rewriting its chemistry through massive carbon emissions and mineral extraction. Geologists are actively debating whether we have officially left the stable Holocene epoch. Many argue our technological footprint has pushed us into a contested, human-driven state known as the Anthropocene. When we look at global environmental disruptions, we usually treat them as isolated crises. But massive plastic accumulation, collapsing biomes, and extreme weather are the explicit, mechanical symptoms of a planet actively crossing a critical threshold. Now we are outsourcing the processing itself. Artificial intelligence represents a final shift where information processing moves into non-biological silicon, detaching logic from the limitations of the human mind. For the first time in 4 billion years, a single species and its artificial technological complex are actively dictating the physical parameters of the entire globe. Global warming, pandemics, and pollution represent the mechanical friction of a planetary flip occurring in real time. If we fail to actively manage our own technological complex, we risk the Earth system settling into a final state that is openly hostile to human biology. AI and global networks occupy the current frontier of a 4 billion year continuum. They represent the same kind of evolutionary shift that once moved life from simple cells to complex organisms. This convergence of biology, technology, and climate brings us to the singularity. It marks the definitive boundary between the strictly biological era and the onset of an entirely new Earth state. To navigate this, we need a map. Researcher Jonathan Cowie outlines this exact trajectory in his work, Earth's Flips of State. By understanding the deep time co-evolution of life and planet, we can anticipate the mechanics of the transition we are currently living through. Humanity must actively steer this final transition. If we do not, we will simply become another thin, fossilized layer embedded in Earth's hidden pattern.